Hi, my name's Robert. This is Bala. Today we're going to look at how Cisco stacks up to Aruba's multimedia-grade Wi-Fi. This is really a response to two major trends that we're seeing today. First, people are bringing their own devices like tablets and smartphones into the office. And second, the applications running on these devices are much more likely to be video and voice-based. So what we're finding is that a new class of Wi-Fi network is required, a network that's truly multimedia-grade. What we want to do today is not just validate some of the architectural advantages of the Aruba solution, but actually battle it out directly with Cisco. As you know, getting high-definition video to work on a mobile device, be that a laptop or an iPad, is only half the battle. The bigger problem is getting it to work in a busy environment. What happens, for instance, when an organization sends a live video communication to its entire workforce, or when a lecture hall at a university runs a video-based learning application? The test we're going to run is actually pretty simple and reflects this real-world challenge. We'll just be streaming unicast video to a handful of devices and then adding some data traffic, just like you'd see in a typical network environment. Bala, one of our technical marketing engineers, will be running the test. So Bala, can you tell us a little bit about the setup?
Sure. So as you mentioned, we'll be running this test on both a Cisco and Aruba network. We are comparing Aruba's AP105 with Cisco's latest 3500 series access points. We have a mix of laptops and the iDevices that include some iPads and an iPhone connected in the 2.4 GHz band. Both the systems are running the latest code and they're configured based on the vendor's best practice guide.
Okay, so everything's configured to spec. What's next?
Well, we want to make this look like real campus environment. So we won't just be sending video to each client. We'll also be pushing data in the background, like you would see if there was a real file transfer in a real classroom.
Okay. Before moving forward, can we look at the RF environment, see what it looks like? Do you have any tools where we can show that?
Yes. We can use the integrated spectrum analysis capability on the Aruba APs to see that the RF environment is consistent for both vendors. This is not a clean environment because we are running the test in an active corporate building, but it is the same for both the vendors. So there is no unusual interference that could affect the outcome of these test results.
Okay. So can you tell us what you expect to see?
Well, Aruba does have two very compelling architectural advantages that shine here. For application performance, Aruba has the advantage of a full stateful application-aware firewall built into the controller. And for a mix of different devices, Aruba has the advantage of intelligently allocating wireless capacity using airtime fairness.
Okay, so I think most people associate Aruba's firewall with securing mobile users. Can you tell us a little bit more about how it's used to make applications like video and voice work better?
The firewall is actually very important for this application performance because it allows you to segregate and prioritize traffic by sessions, whereas other Wi-Fi solutions like Cisco don't have this application context. It's not layer 4 to layer 7 aware, so it has to apply quality of service to the entire device, which is tied to a specific SSID and a VLAN.
Okay, and you mentioned that airtime fairness will benefit Aruba when there's a mix of clients. Can you explain this?
The challenge with wireless is that it's a shared medium. And so when one device that's transmitting at a slower rate will impact everybody else and bring them down to the same slower rate. But Aruba solves this by allocating airtime fairly among devices, regardless of what type of device it is. This has a significant impact as you try to deliver multimedia, especially in a dense environment.
Okay, so let's run the test then.
We are actually already running video on 4 devices. 2 iPads, 1 iPhone, and 1 Windows laptop. They are currently all connected to an Aruba AP. We are pushing video as unicast, which in this particular case is a limitation of the client device. The iOS currently doesn't have a video client that will receive multicast. So this is a HD video running at about 6 megabits per second. And as you can see, each system is connected and is streaming just fine.
Okay, now let's make this a real-world test and see what would happen if someone makes a file transfer or some other background data traffic exists.
Okay, so we are now injecting 4 streams of TCP downstream traffic into the network. And let's see what happens to the video. Aruba stays up and is running just fine.
Okay, so as you can see, all of the application and RF performance techniques that Aruba uses are really doing their job quite well. The network has identified and applied priority to the video sessions, and it's using airtime fairness to optimize RF capacity. So now let's try with Cisco the exact same test.
So we have switched everything over to a Cisco wireless LAN now. So first we can see that the clients are passing video traffic just fine when it's in a controlled environment with video only. Now let's turn this into a real-world environment and inject some data traffic like we did previously. As you can see, because Cisco has no awareness of the applications traversing the network, they can't set priority on the video, and it becomes completely unusable. Having a mix of devices without airtime fairness makes matter even worse.
So Cisco isn't applying priority over the air then?
The Cisco architecture isn't layer 4 to layer 7 aware. They're hoping that the application will be smart enough to specify priority. But if you look at the vast majority of the applications for these devices, they just don't do it by themselves. But with the Aruba, the network is designed application aware, so that it will dynamically adjust to keep latency sensitive applications like voice and video running smoothly.
Great. Well, thank you for the demo. To learn more, please visit arubanetworks.com/multimediagrade. Thank you.
Thank you.